So today what I'm going to do is I'm going to show you how we can prepare a dry crystalline salt from an insoluble metal oxide. So the crystal that we are going to prepare hopefully by the end of the lesson is copper sulphate crystals, but the insoluble metal oxide that I'm starting with is copper oxide. Now the first part is the fact that it is insoluble in water. So I've got a flask of water here. I'm just going to put some water into this beaker and I'm going to add a spatula of copper oxide, which is a very fine black powder. Now if the two were to react together, the metal oxide and the metal oxide and the water should in theory produce me a soluble salt. But I'm going to give it a good shake and I'm going to leave that on the side for a moment to settle out, and hopefully when it's settled out in a moment you will see that that substance was totally insoluble in water. But what I am going to do is I'm going to replace it this time. I'm going to do the same again, but I'm going to use sulphuric acid. So I'm going to take a quantity of sulphuric acid, I'm going to put it into a beaker, and then what I am going to do is I'm going to add again some insoluble in water copper oxide, but hopefully the copper oxide will react with the acid. So drop the spatula in. You can see that there are some bubbles. I'll give it a little bit of a shake and we will see if the two look any different. Okay, you can see now that the water one has begun to settle out. If I hold it up and we can get a close-up of it, you should be able to see that the solution or the liquid is still colourless, but it has a suspension of black powder in it, which is the insoluble copper oxide, which has also sunk to the bottom of the beaker. With the acid, okay, what I'm going to do is to speed up the reaction. I'm just going to place my copper oxide and sulphuric acid onto the tripod and stand, give it some warmth, use a glass rod, and I'm going to stir it so it reacts. Now, I am going to cheat a little bit and filter some of this just to show you that the liquid is a different colour. Okay, but we would leave that now for a considerable time and keep adding copper oxide until the black powder no longer disappears. We must have an excess of the copper oxide at the bottom of this beaker, because that way we know that all the acid has been used up. I will just have then copper sulphate solution and copper oxide powder to excess in the bottom. So I'm just going to pull my Bunsen out for a minute. I'm just going to take that off there, it's not too warm. I'm going to put it on there, fold myself a filter paper in half again, put the filter paper into a filter funnel, so the beaker for a moment. So I'll filter now the one that was with the sulphuric acid, and I will also filter the one that was in water, just to show you that the water has done nothing, but the sulphuric acid has started to react with the copper oxide to produce copper sulphate. So that one in, pour the water and copper oxide through, leave that one for a moment. Now if I look at this one, you can see there has been a reaction taking place. The copper oxide has started to react with the sulphuric acid, producing a blue copper sulphate solution. As I said to you before, I would continue to add more and more of that and make sure I did have a black residue left at the bottom, which shows I have used all of the acid up. You can see with this one that the solution that's come off is still clear and colourless, so it's still water, so that is showing that the copper oxide is insoluble in water. Okay, we're going to come back to an example of this in a few minutes' time when the reaction is taking place a little bit longer.